Uh, Hello dear student, welcome to the new lecture, that is lecture 2 of this course. Although this is not exactly the lecture 2, but yes, for a better understanding I had just written lecture 2 because we had completed I guess one or two videos before this. Okay, so in this particular lecture we are going to just revise the concepts which we had learned in course 2. Yes, we had learned this particular concept of forward bias and reverse bias in my course 2, that is semiconductors, but again, because we need to simulate this particular circuit in course 2, we didn't simulate, like, yeah, we simulated that circuit. See, we simulated this particular circuit on the tinkercad software. Okay, but now we need to simulate this particular same circuit on the electric circuit studio software. Okay, but before that, let's see that what exactly it is forward bias. So as I told you earlier in course 2, in forward bias basically we connect the positive terminal of battery to the p type, or basically anode of this particular p-n junction diode. So this part is anode part, and this is cathode of p-n junction diode. Okay, and I had also given you the reason for this is that this arrow is pointing towards this direction. That means this should be the positive side. That means, see how current flows. Let's suppose if this is your resistor. Okay, this is positive terminal of resistor, this is negative terminal of resistor, then current will always flow in this direction. Why? Because current flows from higher potential. So positive side, that means it is on the higher potential, and this means it is on the lower potential. And basically we represent current with the help of this arrow or this particular symbol. Correct? So similarly, in p-n junction diode, this particular symbol represents that the current is only able to move, or it is only allowed to move in this particular direction. It won't flow in this direction. Okay, so this is what it means, provided you are connecting the p-n junction diode in this way with respect to this the battery polarity, which is in this way. Okay, so let me erase this thing as well. Yeah, so this is the positive side of the diode, I can say, and this is the negative side of the diode. Okay, so forward bias means what? You are connecting p with p. The basic full form, you are connecting positive terminal of battery. I'm not writing everything because I had written over here. Positive voltage of the battery is connected to the anode or the positive terminal of the diode. Okay, positive terminal of battery connected to positive or anode part of diode. Anode of diode, p-n junction diode, obviously. Oh, sorry, I think there is some lag in software. Yeah, diode. Yeah. Okay, and obviously if you are connecting p with p, that means anode with positive terminal of battery, then the negative terminal of the battery would be connected with cathode of the diode. Okay, or the negative side of the p-n junction diode. Okay, so this is forward bias, and due to this, what will happen if you are providing voltage greater than 0.7 volt at that particular time? I told you why we are why this particular the voltage is 0.7 volt, because of depletion layer. Okay, so I know that I'm not explaining the internal structure of diode and all, because I had already explained that particular concept in great depth in my course too. So it's my request, if you don't know this particular thing at this particular point, then please do go and learn that particular thing from a course too, because I had explained that thing in great depth. Okay, so here the barrier potential or the depletion layer, it is zero point 0.7 volt. Okay, depletion layer is also known as barrier potential, it's one and the same. Okay, it is 0.7 volt. So if v, okay, so this particular v excitation voltage is greater than vd, that is depletion layer voltage. Let's suppose it is 1 volt, and here this particular voltage is fixed vd. This is plus minus vd, depletion layer voltage. 1 volt is obviously greater than 0.7 volt, then current is going to flow in this particular direction. Okay, that is current is flowing in this particular direction. So the main pointers to remember in forward bias is that in forward bias, positive voltage of the battery is connected to the anode of the diode. Okay, that means p is connected to p. This is the short form. P type of the diode is connected to the positive positive terminal of the voltage. Okay, and when you connect this particular thing in this fashion, then obviously current is going to flow in this particular direction, okay, provided what, your excitation voltage or the voltage which you are applying, external voltage, external excitation voltage, okay, excitation or external voltage, it's one and the same, is greater than the depletion layer voltage or the barrier potential, which is 0.7 volt, okay, then then only the current is going to flow. So this was all about the forward bias. And then moving to reverse bias. So this is the N type of the reverse bias, sorry, diode, and this is P type of the diode, okay. So in this particular scenario, what you are doing is that you are connecting the positive terminal of the battery to the negative or the cathode of diode, okay, and the negative terminal of the battery you are connecting it to the anode of diode. So let me write over here as well, this is your cathode, this is your cathode, and this is your anode, okay. So basically you are you had just reverse the terminal of the battery, okay, otherwise rest all things are same, okay. See, you are connecting P to N and N to P, okay. So basically you had reverse the polarity, and due to this what is going to happen is that, see, your excitation voltage, let's suppose even if I am giving plus 5 volts over here, but for this particular terminal it is plus 5 volt, okay, that means you are providing positive phi to the N junction and negative phi, let's suppose negative 5 volt to the P junction. So due to this your depletion region increases. Let me write over here, in reverse bias condition, since your V, that is excitation or the external voltage, is less than, very much less than the depletion layer voltage, okay, that is, let's suppose if I am, see, with respect to P terminal, okay, I am applying minus 5 volt, which is very much less than 0.7 volts, okay. Due to this the depletion layer increases, depletion layer or the depletion region or the depletion layer of diode increases and increases, and therefore current can't flow, because obviously current flows because of electrons, okay. See, this is your diode, this is that particular junction, and is this particular junction increases, okay. So let's suppose this was your junction, let me erase this, and after that what is going to happen, since you had connected this diode in reverse bias or in reverse fashion, due to this the depletion layer is going to increase somewhat like this, okay, by decreasing the P type. So let's suppose this is your P type and this is your N type, okay. So earlier your N type was up till here, okay, and your P type was up till here, okay, but now due to reverse bias, but now you are connected this diode in reverse bias condition, that means you are giving negative potential over here, and you are providing positive potential on this particular side. Due to this, oh sorry, extremely sorry, yeah, due to this what is going to happen, the electrons are getting swapped in this particular direction, this is your electrons, and these are your holes which are getting swapped in this particular direction, thus the depletion layer increases, internal structure of diode, this is, okay, and thus the current can't flow in this particular scenario. So this is what I had written over here in for, oh sorry, here it should be reverse, extremely sorry students, this is my mistake, here it should be reverse, yeah. In reverse bias condition, positive voltage of the battery is connected to the cathode. See, positive battery is connected to cathode, so this is your cathode, okay, cathode of the diode, and the negative to anode. So as you can see, negative terminal of the battery, yeah, negative terminal of the battery, it is connected to anode, this is your negative terminal, and this was your positive terminal, okay. In reverse bias condition, diode does not allow the current to flow, okay. This is what I told you, since the gap between the P type and the N type increases, that means the depletion layer increases, and due to this electrons can't jump from N type to P type, okay, electrons, so let's suppose this is an electron, they can't jump to N type to P type very easily, obviously there is some jump of electrons from p type to n type, that is the minority electrons, which we will be coming further. Okay, so you did not to worry, I will be explaining this particular thing while doing the graph, that is vi characteristics of p-n junction diode. During that particular time I will be explaining this particular stuff. Okay, so these are the two things which you need to remember. In forward bias, the the diode allows the current to pass. Okay, so yeah, the two things is like, see, p type to pp, that means positive terminal of the diode to the positive terminal of the battery, and negative terminal of the battery to the negative terminal of the p-n junction diode or the cathode. And second is that in forward bias, diode allows the current to pass, okay, or diode allows the current to flow through it, provided your external or the excitation voltage is greater than the depletion layer voltage. That is, let's suppose if I am applying 1 volt, obviously 1 volt is greater than 0.7 volt, because the this depletion layer voltage, it is 0.7 volt. Okay, moving further, this is your reverse bias state, where you are connecting the positive voltage of the battery to the negative type or the cathode of the diode, and negative terminal of the battery to the anode of the diode. Okay, and yeah, this is reverse bias. Actually it was my mistake, I by mistakenly type here forward, extremely sorry for this. Okay, and due to this, what is happening, your depletion layer between p and n junction, it increases, and thus it does not allow the electrons to swap from n type to p type very easily. And due to this, what is going to happen, the current won't flow in reverse bias condition. So this is what I had written, current does not allow the current to flow through it. Okay, so I hope you understood this basic concept. Okay, and I'm stopping this video over here, and in next video, actually this video is continued form of the, sorry, that video would be the continued form of this particular video, where we would be implementing these two particular circuits on the electric circuit studio software. Okay, so thank you for listening me patiently. I hope you understood this particular thing. Thank you.